Okay, we're going to work on creating quadratic formulas from graphs. Okay, so we have two graphs here. I kind of accidentally drew a third one, but we only really need two major ones. So we have these two graphs, and the first thing we're going to do is just relate it to our three forms. Okay, so maybe in red I'm going to say standard. Standard form. Standard form is usually written as like y equals a x squared plus b x plus c. Is this familiar to you?
Mm-hmm.
Yeah? Great. There's vertex form, which is usually written as y equals a x minus h, and then plus k at the very end. And finally, factored. Factored is usually written as y equals a, which is our very nice and common value, x minus r, x minus s. Do you guys use r and s, or?
Yeah.
Yeah, you can use any letters for those. Okay, here's our three major forms. Right off the bat, I'm just going to tell you, when looking at a graph, it is extremely difficult to take any points on a quadratic and put it directly into standard form and build. So this is like almost unideal. You really don't want to work with this one. In fact, since I learned how to draw a line like 10 seconds ago, can I do a red line? Huh. Okay, anyways, I was hoping those would turn into straight lines. They didn't. We're going to really focus on creating a vertex or a factored form, and you do need pretty specific points to do it. Otherwise, you can get like more difficult processes to solve it out. But let's talk about the two we have. So the very first one, it's given us the lowest point on a quadratic, and technically this is a y-intercept. Now, very quickly, y-intercepts can be put into standard form, right? I can get c really quickly. It just becomes now, how do I solve a and b, which is a little difficult. But besides that, this here is the lowest or highest point is known as the vertex. And if you recall, I'm going to write it like this, the x value of the vertex, I'm going to do like x subscript v for vertex and y subscript v for vertex are also the h and k values. Okay, I know I have a lot of different abstractions there. They're the h and k values. In other words, I can plug in for h, right? And I can plug in for k really quickly. And then the last thing I do, I have to solve for a. So that's really nice. On our other hand, graph number 2, I haven't been given a vertex, but I've been given two roots. I've also been given the y-intercept again, which again gives you your standard form really helpfully, but not the b or the a from it. But if we have the two zeros or x-intercepts, these are your r and your s for your factor form. So depending on what you've been given in a graph or what you can solve, you can replace the r and the s here, and then again you only have to solve for a. So we're going to kind of go through the process of doing the first one, vertex form, okay? So y is equal to a is unknown, x minus, now the h value was the number 4, okay? So we say x minus 4 plus, and then the k value was 3. That's nice, except we still need to find a. That's where the other point is extremely important, because technically the other point has an x and a y value, and we're actually going to replace this x and this y with them, okay? So in other words, the x value of 0 will replace this, the y value of 4 will replace this, then we'll isolate for a and rewrite the equation.
Okay.
So this is how we would build it. So, let's give it a quick try here. Nope, that's what I want. So the y value is 4, is equal to a still unknown. The x value is 0, minus 4 squared plus 3. Okay, and now I start to isolate for a. I'm going to bring the 3 to the left side of the equation. That becomes 4 subtract 3 is equal to, still looking for a, okay? And I'll quickly do that actually, that's not that difficult. 0 subtract 4 is just negative 4. Okay, 4 minus 3 is 1. 4 squared is actually 16. And because this is a multiplied by 16, we would divide. To bring it to the other side, we divide by 16. So in other words, your a value is going to be 1 over 16. Okay? So when we go to rewrite this entire equation, we get y is equal to 1 over 16, which is the a value, x minus 4 squared plus 3. So graph number 1, that's the equation for it. Okay? Graph number 2, I have to shrink again just a little for it. Same idea, but this time we're going to replace the r and the s. So a x minus, and technically that's -2, so it's x minus -2. I'm going to put it in like that, and I just want you to be aware. And then x minus positive 6, which we're not going to do anything to simplify. I'll quickly simplify that bracket. Y equals a x plus 2, x minus 6, okay? Now, again, we have a y and we have two x's, and that's where that third point is really important. The x value, change the size of that dot, there you go. The x value will replace both of these x's, and the y value will go into here, and then we'll isolate for a and solve the equation again, okay? So we'll go through that process one more time. The y is the number 3, so we're going to plug in 3, is equal to a still unknown. The x value was 0, so I'll write 0 in blue. 0 plus 2, 0 minus 6. Okay, and now it's just a bunch of simplifying and isolating. So 3 equals a, this becomes 2, this becomes -6. I'm going to multiply those two numbers. 2 times -6 is -12. So 3 is equal to a times -12. Same concept as before. To bring it to the other side, we are going to divide. Technically, you divide both sides by -12, and this side just kind of cancels out. My dog is getting on my nerves. And 3 over -12 can be simplified as actually 1 over 4. So it's -1 over 4. So when we go to rewrite the entire equation, y is equal to negative? It can't be negative. Sorry, this was -3. Do you know why it couldn't be negative? When your a value is negative, your quadratic goes downwards. And this one's opening up. So right away, I'm like, there's a problem. This should have said -3 divide -12, which gave us positive 1 over 4, okay? So 1 over 4 is equal to times x plus 2, x minus 6. So that's the equation for the second one. So you always, two things you got to remember, if I have two zeros or x-intercepts, I'm going to work with vertex form. If I have the vertex, I said that wrong. If you have the two zeros, we're going to work with factored form. If you have the vertex, you're going to work with vertex form to build the equation.
Okay.
Okay?